Building on our understanding of control flow and functions, we're now diving into Python's core data structures. These are the building blocks for organizing and managing data in your programs. Each structure has its own strengths and use cases, and understanding when to use each one is crucial for writing efficient Python code. Today's lesson builds directly on our previous work with control flow. Now that we know how to make decisions in our code, we'll learn how to organize and structure data effectively. Understanding these data structures is crucial for writing more complex and efficient programs. We'll see how control flow concepts like loops and conditions work seamlessly with these data structures. Lists are Python's most flexible data structure. They're mutable sequences that can hold any type of data. Think of them as dynamic containers that can grow or shrink as needed. The square bracket syntax is used for both creating lists and accessing elements. Remember that indexing starts at 0, and negative indices count from the end. Lists maintain the order of elements and allow duplicates. List methods provide powerful tools for manipulating data. Notice how some methods modify the list in place, like sort and reverse, while others return new values, like pop. List comprehensions offer a concise way to create lists based on existing sequences. They're both readable and efficient. Understanding these operations is crucial for effective data manipulation in Python. Tuples are immutable sequences. Once created, they cannot be modified. This immutability makes them perfect for representing fixed collections of values, like coordinates or RGB colors. Tuples are commonly used for returning multiple values from functions and for situations where you want to prevent accidental modification of data. The parentheses syntax distinguishes them from lists. Dictionaries provide a way to store and retrieve values using unique keys. Unlike lists which use numeric indices, dictionaries use keys that can be strings, numbers, or any immutable type. They're perfect for representing structured data like user profiles, configuration settings, or any data that has natural key-value relationships. The get method provides safe access with default values. Dictionary comprehensions provide a concise way to create dictionaries, similar to list comprehensions. Nested dictionaries allow us to represent complex hierarchical data structures. Methods like update and setDefault provide powerful tools for managing dictionary content. Remember that dictionary keys must be immutable, but values can be any type, including other dictionaries. Real-world applications often require combining different data structures. Lists of dictionaries are common when working with data from APIs or databases. Dictionaries of lists are useful for categorizing or grouping related items. Notice how we can use our control flow knowledge, loops and conditions, to process these complex structures effectively. These advanced operations provide powerful tools for data manipulation. Slicing works with both lists and tuples, allowing us to extract portions of sequences. Dictionary merging with the operator, Python 3.9+, provides a clean way to combine dictionaries. Unpacking with asterisk is particularly useful when working with arbitrary length sequences. These features make Python's data structures even more versatile. This example shows how different data structures work together in a real application. We use a list of dictionaries for input data, a dictionary for aggregating results, and lists for tracking top products. Notice how we combine loops, conditions, and different data structure operations to process the data. This pattern is common in data analysis and reporting applications. Choosing the right data structure is crucial for writing efficient and maintainable code. Lists are great for ordered collections that change, tuples for fixed collections, and dictionaries for key-value relationships. Consider performance implications. Dictionary lookups are generally O(1), while list searches are O(n). Keep data structures as simple as possible. Deeply nested structures can become difficult to maintain. We've covered Python's main data structures and their operations. Understanding when to use each type and how to combine them effectively is key to writing good Python code. Remember that these structures are the foundation for more complex data manipulation and algorithm implementation. Practice working with these structures in different scenarios to become proficient in their use.